Okay, we're going to be talking about lesson 5.4 and lesson 5.5, which is going to be graphing radical functions. Okay, now the two radical functions that we are going to talk about is we're going to talk about graphing our square root function, which would just be y equals our square root of x. Okay, we're also going to be talking about graphing our cubed root function, which is just the y equals the cubed root of x. Okay, and we're specifically going to be looking at those two functions. So you'll have a new parent function and another new parent function, along with, don't forget, we already have our y equals x squared, which your y equals x squared is your parabola, 0, 0, 1, 1, 4, 2, negative 1, 1, negative 4, 2, makes that u. We've also gone over our absolute value function, which, remember, is our absolute value. So 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2, and that one makes our v. Okay, so today we're going to learn square root, we're going to learn our cube root, and then you're going to learn about how the shifts will work between those two as well. So, starting off, graph of a square root function. Okay, so remember, when we do these, we start out with our function, and since we don't know what they look like, we always start out by making a table. Okay, I've got negative 2, negative 1, 0, 1, and 2, same ones that I've been using all along. Okay, I'm going to start out with y equals the square root of, first x, let's look at 0. So what does y equals the square root of 0 give us? Well, that gives us a y equals 0. Okay, so 0, 0 is a point on this graph. Okay, next one we're going to look at, let's look at 1. Okay, so we're going to go y equals the square root of 1. Okay, x is 1, plug it in. What is the square root of 1? Well, the square root of 1 is 1. Okay, so the point 1, 1 is on this graph. Okay, next we have a 2. Okay, we're going to plug in a 2. Y equals the square root of 2. And that's like 1.14 or something. So that's really not going to be very easy to do for our parent function. So this is the first one we've had where 2 really isn't a good option. 2 really isn't a good option. What could I plug in underneath the square root that would give us some sort of like an even number down there? Good job. 4. We could plug in the square root of 4. So instead of having a 2, we should have an x value with the square root of 4 because we know that the square root of 4 is 2. Okay, oops, I wrote down the wrong number there. My bad, kind of gave it away. So our x value should be 4, which if our x value is 4, that makes our y 2. So the next point on our square root function is going to be 4, 2. Okay, it's going to be 4, 2. All right, now let's work the other way. Let's work our negatives. What is the square root of negative 1? Well, we just talked about this, but that is an I. An I is not a real number. And the issue with that is, yeah, we know how to do that now, but can you graph a number that's not a real number? No, because this is a real number coordinate plane. Okay? So this is not real, and in fact, neither would our negative 2. Or even if we were like, hey, we should look at our negative 4, any negative number is not going to offer us a real solution. Okay? So none of these points that we plug in, they won't give us points. Okay? So this function is kind of weird. I'm going to be honest, guys. This is your first function. This function will only have 3 points. It will only have 3 points, and it looks just like this. Okay? It starts at 0, 0, and then just goes through those 3 points. There is nothing moving to the left. There's not an arrow at the end of it on the left. It's just those 3 points. It's got a little nub in here to start, and it rotates on. Okay? So that is your square root function. Okay? Now, we go through these. Remember, we do our inside and outside and all that stuff. Okay? Well, in order for something to be on the inside, okay, it can't be out in front of the square root. It's only things that are underneath that square root. Okay? Anything under the square root is going to cause a horizontal change. Anything out in front or anything back behind will give us our vertical change. Okay? All right, so that's our square root function. That's our first parent function. Now let's look at our cubed root function. Now let's take a look at our cubed root function. Okay, so cubed root, I've got y equals the cubed root of x. Okay, y equals the cubed root of x. So same as before, we're going to start out y equals the cubed root of, and we're just going to start plugging numbers into that. Okay, so first one, let's start with 0. Y equals the cubed root of 0. That gives me a 0. Okay, so 0, 0 is a point on this graph. Okay, 0, 0 is a point on this graph. Next one we're going to look at 1. Y equals the cubed root of 1. What is the cubed root of 1? It is just 1. Okay, so 1, 1 is a point on this graph. Okay, next one. Remember last time we tried to do 2, but 2 didn't work. Okay, so we're not going to do that 2. We're going to do our 4. Okay, so what's the cubed root of 4? Biscuits. I don't know what the cubed root of 4 either. What could I do instead of the cubed root of 4? What's the next cubed root number? Oh, yeah, good job. The next cubed root number we would want to look at would be 8. The cubed root of 8. Because we know that the cubed root of 8 is 2. So 8, 2 is a point on this graph. Okay, now sometimes when I give you guys these graphs, they don't have enough. I believe on your homework I did give you guys enough so that you can mark them. But 7 is right there, so 8 is going to be just one step outside of it, so I just kind of added that there. Okay, now we move to our negatives, okay, and remember, we're going to start with -1. What happens when I plug in -1 underneath a cubed root? If you said it gives you a not real number, you are wrong, okay? Remember, when we are dealing with a cubed root, it's the opposite of something being cubed. If you multiplied 3 -1s together, it would still give you a -1. So therefore, y equals the cubed root of -1 gives us -1. And if you don't believe me, you can plug it in your calculator to know for sure. Okay? But I promise you, the cubed root of -1, it is okay to have negatives if it is an odd root. It's only okay to have negatives if it's an odd. So cubed roots, negatives are okay. Then I'm going to plug in, well, not -2, right? We did 8 down below, so what if we did a -8? Plug in a -8 here, and that gives me, you guessed it, a -2. Okay, so -1, 1 is on here, and then -8, -2 is on here as well. Okay, so this function, I kind of call it the snake function, because it's just kind of a little snake slithering across the graph there. Okay. Now, just like with our square root function, the only way you're going to get some sort of a horizontal change to happen, not if anything's out in front, it's only if it's down underneath that square root there. Okay, anything added or subtracted back behind it will be vertical. Anything out in front will be vertical. The only way you get a horizontal change to occur is if it is underneath that root, which goes along with our inside. Okay. Next video, we're going to run through shifts. We'll do one shift for something on the inside, one shift for something on the outside, and then we'll look at both cases of negatives, and then we'll do a few more practice ones as well.